Hello dear friends, welcome to Gate Academy Global. So before starting today's session, I would like to have the input as well as concurrence regarding the quality of video as well as audio. If it is perfect, just write perfect over the live chat and then we are ready to go ahead. Anyways, the agenda behind today's video must be known to all of us. The student who have been attending my class since very beginning had a little bit idea. The today's class would be the last class where we are building our concept through the question, and the topic which we are going to take in today's class is going to be the second order system. So approximately 8 number of questions I am supposed to take. This has been the first question which had been experienced by the gate instrumentation, year of 2004, and the problem was framed by IIT Delhi. In the same sequence, we are going to have the next question which had come in gate electronics year of 2015. The problem was framed by IIT Kanpur. In the same sequence, we are going to have the gate electronics 2008. The problem was framed by IIT Bangalore. So lump sum the different kinds of the problem which we are going to take, no, I won't say they are easy problem. So comparatively, the questions which we have taken in the last 2 class, I would have a little bit tougher problem. Anyways, keeping aside each and everything, let me focus over the first question first, and here comes the first question. Tell me what would be its best most answer. The problem states the dominant pole of a servo system. Again I say, whether it's been a servo system, whether it's a chemical process, whether it's a mechanical process, whether it's the electronics process, you need not to worry at all. The control system, the concept of the control system remains same for all of the stream. So focus over the transfer function, focus over the locations of the pole, focus over the locations of zero. You need not to worry, sir, the servo system had been written in this problem, sir, how can we approach? No, you need not to have that approach, at least in control system. Problem says the dominant pole of a servo system are located at S is equals to of -2 plus minus of 2j. The damping ratio of the system is being. The 4 different options were given along with this problem, which had been 1, 0.8, 0.707, and that had been 0.6. Tell me what would be the best most answer for this given problem. Tell me what would be the best most answer for this given problem. Let me do one thing, let me bring this problem towards working board and we would try to smash this problem there itself. So here goes the problem. Tell me what would be the best most answer for this given problem. This problem should not take more than 30 seconds, but still we have been taking so much good amount of time. So the first answer had come from Jayanta. As per him, the answer had been 0.707. Anyone else apart from Jayanta? As per the Amit, the answer had been C. Again, the Amit has been endorsing the same answer, and that had been 0.707. Divya P is also saying the answer would be 0.707. One thing has been quite sure, once you'll focus over the locations of the closed loop poles, or for the time being poles, it had the negative real part and that had been in a form of complex conjugate. That means the value of zeta is supposed to be in between 0 to 1. If rather having -2, if it would have been +2, so the value of zeta would have been in between -1 to 0. That fundamental is already been taught probably day before yesterday. So one thing has been quite sure, as the locations of the pole had been in such, its real part had been negative, and at the same time it has been in form of complex conjugate. Out of the 4 options, definitely A can be ruled out, because zeta, when the zeta is being 1, the poles are pure real, repeated, and had the negative real part. So the option A had been ruled out. Anyways, focus over the data which has been supplied along with this problem. We had the second order system. 2 poles, they had been located at -2 plus j minus j. May you know what used to be the location of the second order closed loop pole? This is being in the place of minus times of zeta omega n. Yes, and this has been in place of omega d, which we also call it omega n root over of 1 minus of zeta square. 1 minus of zeta square. Everybody would agree on it. There is no doubt as such. Agreed what I am saying? So what we can do out of it, just try to understand what I am saying. What we can do out of it, once you take the square of this as well as the square of this, and once you add them together, the result which do come in our hand is being omega n square, which you have already seen, omega n square circle. Yes, no? So whenever you have this sort of problem, what you do, you take the square of its real part as well as imaginary part, and its resultant would be equals to of omega n square. So here it becomes minus 2 which has been raised to the power of 2 plus of 2 which has been raised to the power of 2, and it had been how much? 2 to the power of 2, that's gonna be 4, 2 to the power of 2, that's gonna be 4, and it's gonna be 8 over here. It's gonna be 8 over here. So the value of omega n which we got to know is been root over of 8, could have been written as 2 root 2, could have been written as 2 root 2, and the value of zeta omega n, is being 2, obviously sir, and the value of omega n is been known to be 2 root 2. End of the day, the value of zeta which we have got in our hands been 1 divided by root 2, and the answer which we are supposed to get is being 0.707. 0.707. Could you understand what was the logic behind this problem? Yes, so the total 4 different kinds of the options we have got it so far, and almost all of them are correct. Jayanta correct, Amit correct, Divya correct, and Pikorab Basu, I should say you should take less amount of time for this sort of problem. It had been a problem which can be asked for the 1 mark. The concept behind this problem is being clear. The real part is being standing for minus zeta omega n, imaginary part is being standing for the omega n, root over of 1 minus of zeta square. Once you will take the square of both of the side and once you add them together, what is happening? Zeta omega n square, and this is going to go off, and only factor which has been left out is being omega n square. End of the day, the zeta has been known to me. Zeta has been known to me. In the same sequence, I think it's the right time to move forward, taking the next question. Here comes the next question. The problem had been experienced by the electronics people in year of 2015. The problem have come in year of 2015. Let me bring this problem towards working board. We had the problem over here. Read this problem carefully and try to get its best most answer. The problem says the output of a standard second order system for a unit step input is being given as y of t is equals to of 1 minus 2 divided by root 3 e to the power of minus t cos within the bracket root 3t minus of pi by 6. The transfer function of the system is being, the 4 different options were attached, type of MCQ. The first option is being 2 divided by of s plus 2 getting multiplied with s plus root 3. The option B had been 1 divided by of s square plus of 2s plus of 1. Option C had been 3 divided by of s square plus of 2s plus of 3, and the option D had been 4 divided by of s square plus of 2s plus of 4. Tell me what would be the best most answer for this given problem. I know many of the students would try to solve this problem completely with the help of manual method, but unnecessarily you are going to waste your precious amount of time. So I would say use Jugaad method and try to get its best most answer. So the answer have started coming. As per the Pikorab Basu, the option is being D. As per the Amit Kumar, answer had been D. Anyone else apart from the 2 options which we have received so far? Jayanta Hajar also says D. It looks unanimous, same as D. Let me focus over the question, and we are going to use the 2 different methodology to smash this problem out. We are going to use the 2 different methodologies. Once you will see its response, may I know whether the type of response had been over damped, has it been under damped, or whether it had been critically damped. As the time passes on, what would happen? It would be keep oscillating. What I am saying, it would be keep oscillating, no? Yes sir, it would be keep oscillating, no issue as such. It would be keep oscillating. Not only that, even the factor of e to the power of minus t would be keep dominating. And as the time passes, the factor of e to the power of minus t would be keep shrinking the oscillation. And as it is being keep shrinking, what would happen? At steady state, it would go towards a finite converging value, So one thing has been quite sure, if it had been a type of damping with, oscillation with the damping, so it's gonna be a case of under damped system where the zeta has to be in between 0 to 1. There is no doubt as such what I am saying. The zeta has to be in between 0 to 1. So what we are going to do over here, we are going to filter out few of the options which may not be relevant to this particular option. See, B has been ruled out. Why the B has been ruled out? Because the 1 has been in the place of omega n square. If the omega n square has been 1, so obviously omega n would also be 1. And here it had been the place of 2 times of zeta into omega n, where the omega n had been 1. So obviously the value of zeta, at least for this problem, is been 1. Obviously it had been ruled out. Obviously it had been ruled out. Option B had been ruled out. Could you understand what I am saying? Obviously it had been an underdamped system. Option B had been ruled out. Not only that, even option A is also been ruled out. Now many other people would also say, sir, how did I know about it? My dear friend, if we'll talk about its steady state value, tell me what would be the steady state value? YSS. Yeah, the things has been given in time domain. You have to just feed t tends to infinity. What I am saying, you have to just feed t tends to infinity. And once you'll feed t tends to infinity, no, this factor e to the power of minus infinity would dominate over the complete oscillation, and the resultant which we are supposed to get, it's been 1. It's been 1. So one thing is again quite sure, what I am saying, one thing is again quite sure, the multiplier factor k has to be 1 for this transfer function. So if you multiply them together towards denominator side, we have been getting 2 into root 3, whereas towards numerator we had been getting only 2. What does that mean of it? That means for the option A, if option A is being excited with the unit step input, its steady state worth is going to be 1 upon root 3, whereas as per the problem, we had to stack, or we had to finalize our value precisely at 1. So obviously A had also been ruled out. A had also been ruled out. But C and D cannot be ruled out. C and D cannot be ruled out. Or is it? We'll try that. What would be its steady state value? Tell me. I would like to have the input from each one of you. What would be the steady state value from C as well as D? C as well as D. Preparing for BRC, sir, any kind of session regarding BRC answering pattern as time is lesser over the, my dear Picorab, okay, precisely at 9 p.m. we are going to have the session on our Gate Academy channel today. There the mode of communication is supposed to be Hindi. Definitely I will come across a new session there, I would be communicating in English alone, but precisely at 9 p.m. today in our main channel, we are going to have the one-to-one discussion over the BRC. Any kind of doubt, any kind of misconceptions you guys are having, no, you can ask there still. Obviously, here also it's been 1. Here also it's been 1. Whether the zeta is been greater than 0, I do not care about it. One thing has been quite sure, the value of zeta is been in between 0 to 1. How did I know about it? The 4 is been in the place of omega n square, the omega n would be 2, and here it had been 2 into omega n into zeta, and that had been obviously zeta had been 0.5. So may I know which should be finalized as C or D? Which should be finalized as C and D? I would like to have the input from each one of you. Which one should get finalized as a C and D? So what we are going to do, again we are focusing over y of t. I would like to have the input from each one of you. In standard, whether it used to be sine or whether it used to be cosine. Tell me, in standard, when a second order system which had been underdamped had been excited with a unit step input, here I used to have the cosine ratio or sine ratio. Cosine ratio or sine ratio. Tell me whether we used to have the cosine ratio or sine ratio. I would like to have the input from each one of you. Cosine ratio, sine ratio. Sine ratio, yes. And here e to the power of minus zeta is minus e to the power of minus t used to be raised by the factor of zeta omega n. Raised by the factor of zeta omega n. So one thing has been quite sure, once you will see this factor very well, the value of zeta omega n we could have calculated in fingertip. What had been the worth of it? E to the power of minus t had compared with the e to the power of minus zeta omega n t, so the worth of zeta omega n had been found to be 1. That is for sure. And similarly, what we had to do, we had to focus over this factor root 3. May I know root 3 has been in the place of what? Root 3 has been in the place of what I am saying. Root 3 has been in the place of omega d. And how the omega d is been written? The omega d is being written as omega n root over of 1 minus of zeta square, and that had been how much? Root 3 it had been. So this has been equation number 1, this has been equation number 2. So you yourself would be able to understand in the standard second order system, the S gets multiplied with the 2 times of zeta omega n. So obviously 2 times of zeta omega n is been 2, and here also it's been 2, and if we'll focus over the value of omega n, how will I get the value of omega n, which we have already seen? We would take the square of the equation number 1, the square of the equation number 2, and at last I would take its square root. At last I would take its square root. Agreed now? Could you understand what exactly I wanted to communicate? So in that case, what had been happening, the 1 had been raised to the power of 2, that's the 1, root 3 has been raised to the power of 2, that is 3, and once will take its, so we are getting 2. So obviously, which one you are going, yeah, D had been the bestmost answer. D has been the bestmost answer. This has been the omega n square, this has been the value of 2 times of zeta omega n. 2 times of zeta omega n. If you guys are having any sort of doubt, you can ask over here. Otherwise, I don't think any sort of doubt you might be having. So far. So I would say to each one of you, we are going to have a dedicated session on BERC precisely at 9 p.m. on our GATE Academy Global today. So definitely you guys are having any sort of doubt, any sort of ambiguities, you can definitely raise your doubts. I would try to answer almost all sort of doubts you guys are having. Could you really understood what exactly I wanted to communicate? So the one person is been asking regarding the BRC. We are going to have the individual session on our GATE Academy channel precisely at 9 p.m. Keep in mind their mode of communication would be Hindi, no? Agreed. So this has been the answer as far as this problem is being concerned. The answer and be D. What I am saying, if you would judge the problem, no, from there also you would be able to get the same answer. What had been the zeta omega n had been known to me, and that had been 1. So 2 times of zeta omega n has to be supposed to be 2. So it has been 2 here, it has been 2 here, it has been 2 here. You did not rule out. You could not rule out. So now you had to focus over the value of omega n square or the omega n. How will I know about it? This factor and this factor has to get squared and to get added, and once you will do so, you will be getting the factor of omega n square, and at least in that way you can rule out each and everything, and the answer had been D. Agreed. In the same sequence, I think it's the right time to move forward, taking the next question. Here goes the third question. Yeah, this has been the third question. Again, a well-designed problem. I won't say it's a very difficult question, but a well-designed problem had been experienced by the electronics people. In the year of 2008, the problem was framed by ISC Bangalore. Read this problem carefully, and try to give me the bestmost answer for this given problem. Probably the question must be clearly visible to all of us. Otherwise, let me dictate the each and individual words which had been given along with this problem. The problem states, step responses of a set of 3 second order underdamped system all have the same percentage overshoot. Which one of the following diagram represents the poles of 3 systems? Here what had been happening, the complex conjugate pole had been keep shifting in vertical direction, and yes, the real part has not been changing. And here the complex conjugate pole, obviously they had been in a form of complex conjugate pole, and they had been keep shifting towards left hand side. One thing has been quite sure, its imaginary part had not been changing, because neither it is going up, neither it's coming down. Its real part is going more and more negative. Here once you'll see, its real as well as imaginary part both had been changing, but it had been maintaining a fixed angle from negative sigma axis, and here it goes the option D. So the answer have started coming. As per the Amit Kumar, the answer had been C. As per the Pikorab Basu, the answer had been C. So 2 answers we have received so far. May I know what would be the best answer over there? I am not going into the much detailed analysis of percentage overshoot, but one thing has been quite sure. The percentage overshoot had been solely dependent on the value of zeta. What the omega n is doing, nothing to do with that. Could you understand what I am saying? So at least you should have that fair idea that different time domain parameters depends on which are the different basic factors of the second order system. So what I am saying, where it had been written percentage overshoot, the percentage overshoot MP percent is being defined as e to the power of minus zeta pi had been divided with 1 minus of zeta square. As far as this formula is concerned, at least one conclusion you could have retrieved. Pi had been a constant, 1 had been a constant. So one thing has been quite sure, the zeta is only the factor which is going to decide the worth of MP. Zeta is only the factor which is going to decide the value of MP. And we want at least the system to be having the same value of MP. That means I want to fix the value of MP. That means the zeta should not change. Zeta should not change. May I know where the zeta has not been changing? Where the zeta has not been changing, you yourself would be able to judge the locations of the pole, in the standard second order system when it had been underdamped is been minus of zeta omega n, plus minus of what it has been. It's been omega n 1 minus of zeta square, omega n 1 minus of zeta square. What we are going to do over here, just try to understand what we are going to do over here. Let's take the ratio between the imaginary part and real part. What I am going to do, let's take, I have extended a line and we had been seeking the angle theta. So obviously the vertical part, or I can say the perpendicular part, is going to be the imaginary part, and similarly the real part is going to be its base. So once you will divide them together, the worth which we have been getting is been minus of zeta divided by 1 minus of zeta square. And may I know, it would be what? It would be 10. Tangent, no? Obviously it would be tangent. It's going to be zeta 1 minus of zeta square. 1 minus of zeta square. Yes? Yes, no? So once you will use the inverse trigonometry, which you can do very well, I get to know the result had been cos inverse of zeta. You can do that. This has been perpendicular, this has been base, and in case of cos, this has to be base and this has to be hypotenuse. In that case, the worth which we get, it's been cos inverse of zeta, and that had been the worth of theta. So what had been the result out of it? The result had been, if the look angle of the poles which had been underdamped poles has not been changing, by default the theta would not change, and as the value of theta is not changing, the value of zeta would not change. Could you understand what I am saying? So the answer have started coming. Yeah, in A, what had been happening, you yourself would be able to understand. Initially the look angle was smaller and it has been keep raising, and as, just try to understand in this way, as the value of theta is keep increasing, one thing has been quite sure, the value of zeta must be keep decreasing, because the factor of connectivity is being cos, and the cos is being such a trigonometric ratio whose worth continuously decreases when the theta goes from 0 to 90. Yes, no? Cos of 0 is 1 and cos of 90 is being 0. So one thing has been quite sure, if individually you focus over the first question first, and if you say, sir, the pole had been migrated in this way, what would be the effect over the peak overshoot MP? So zeta had been keep decreasing. So I can say in first question, percentage peak overshoot would be keep increasing as the value of zeta is being keep decreasing. Could you really understood what exactly I had been talking about? Yes, sir, we can. In the same sequence, now the complex conjugate pole had been keep shifting towards left hand side. It's been happening. So in that case, what would happen? The theta is keep decreasing. And as the value of theta is supposed to decrease over the period of time, what would happen? The theta is decreasing. What would happen? Zeta would increase, and as the zeta is increasing, MP is supposed to what? MP is supposed to increase. Sorry, here. Okay, so here the theta had been keep decreasing, so the zeta would increase, and as the zeta is increasing, the peak overshoot, either in terms of absolute value, either in terms of percentage value, is supposed to decrease. I would like to have the next question from you guys. Tell me what would be the effect of MP over the option D. What would be the effect over the MP over the option D? I would say it had been keep going in this way. It had been keep going in this way. What would be the effect over the, what would be the effect over the, I repeat, what would be the effect over the MP? Would it increase, would it decrease, or would it remain constant? Would remain constant. Forget about C. I would like to have the answer for the D. As the movement of the pole had been circular in nature, and as the poles had been moving circularly, what would be the effect over the MP? Would it increase or would it decrease? Would it increase or would it decrease? At least one answer I, DS says D decreases. Let me think. What I am saying, the distance from the origin is being constant, and may I know what used to be the radius of it? The radius used to be omega n. So one thing is been quite sure, although the closed loop pole had been changing its location, but one thing had not been changed, and that's nothing but the omega n. And as it has been going towards left hand side, what's been happening? Minus zeta omega n. Anyways, forget about the minus sign. Zeta omega n is being keep increasing. Zeta omega n is being keep increasing. Yes, no? We have already seen the second order system used to have the two poles. The location of the two poles used to be minus zeta omega n plus of omega d. So obviously, as it has been moving towards left hand side, its real part would be more and more stronger. So zeta omega n is being keep increasing. Zeta omega n can increase because of the increment of zeta, could be increased because of the increment of omega n, but in this problem omega n has been untouched. Omega n has been untouched, and as the omega n has been untouched, the zeta is been keep increasing, and as the zeta is been keep increasing, there is no hope MP has to reduce. So Jayant Hajra, perfect answer. Amit Kumar, perfect answer. Srija Kunmala, perfect answer. It's been decrease. It would be decreasing. Anyways, the last option, the best most option for this given problem. Here the theta has been maintained. Here the theta has been maintained. So obviously I can say only one thing. Obviously I can say one thing. And what had been, if the theta has been maintained, zeta would be maintained. Zeta would be maintained. Percentage peak over suit, or the percentage suit would be maintained, and here the MP had been constant. What I am saying, the plenty amount of questions can be framed based on the dislocation of the closed loop poles. Plenty means plenty. Probably I can say 9 to 10 different questions can be framed. And so far probably 1 or 2 questions have come, only 1 or 2 questions have come in GATE and ESE. GATE and ESE. Now forget about each and everything. Let me focus briefly about settling time. May I know, as the pole had been keep displacing from its point towards upward and downside, what would be the effect over this settling time? Would it increase, would it decrease? I would like to have the input from each one of you. Would it increase or would it decrease? The first question it had been. Obviously the answer had been known to me. This problem had the answer as C, but still let me raise another question. What I am saying, let me take the reference of the first question first. What would be the effect of settling time? Would it increase, would it decrease? The answer had come from DS. As per him, the answer had been constant. Anyone else apart from GS? Anyone else apart from DS? As per the DS, the thing would be constant. Obviously, DS perfectly said the TS is gonna be constant. Why so? Because the pole had been keep separating, and that too in the vertical direction. And if it is happening so, one thing has been quite sure. What it is, sir? The value of zeta omega n is not being changing, my dear friend. The location of the pole is being defined by minus times of zeta omega n plus minus of omega n root over of 1 minus of zeta square of z. So one thing has been quite sure, no? The real part has not been changing. If the real part would change, it would dislocate towards left or right hand side. If the zeta omega n is not been changing, you know, settling time with a maybe 2% has been, what had been the settling time with the 2%? It's been 4 divided by of zeta omega n. The zeta omega n itself is not been changing in that case. How can you expect that settling time would change? No sir, the settling time would remain fixed. That's what I am saying, no. So many good questions can be designed based on this problem itself. TS will decrease, settling time would be constant. Obviously, settling time is simply going to be constant. settling time is simply going to be constant. Yeah, perfect, perfect, perfect. Similarly, may I know what would be the effect of settling time because of the shifting of the pole, the manner it had been happening towards left hand side? Settling time, would it increase or would it decrease? Settling time, would it increase or would it decrease? Let me have the next question, which had been a design question. What I am saying, take the reference of option B and tell me whether the settling time, would it increase or would it decrease? Would it increase or would it decrease? Amit Kumar saying TS will decrease. No, that was the wrong answer. Because the real part had not been changing, zeta omega n would not change, and as the value of zeta omega n is not been changing, nothing would change. Sir, I have texted you in Telegram, do read it once. Pikora Basu, yeah, it's not that possible, but still you can tell me which kind of doubt you are having. Decrease, obviously it would decrease. Why? Minus zeta omega n is keep decreasing, minus minus factor goes out, zeta omega n has been keep increasing in terms of magnitude, and as the value of zeta omega n is been keep increasing, Ts relates with the zeta omega n inversely. As the value of zeta omega n would increase, definitely there is no way it has to decrease. It has to decrease. Pikorab, I would say reading the personal message over the Telegram becomes very difficult. I will try, but still if you have any sort of suggestion, any sort of doubt which I can raise over the session which we are going to have for the BRC, definitely you can put it over there, no doubt, you can put it over there. Yeah. Let me focus over which one. Yeah, I can focus over the question number C. Question number C. May I know what would be the effect over the rise time? Because there are several time domain factors which we have studied so far. No, may I know if the poles has been keep sliding by maintaining a certain angle from the negative sigma axis, what would have the effect over the rise time? Would it increase? Would it decrease? Would it increase? Would it decrease? So far I had taken the reference of settling time. For the C, I have been taking the reference of rise time. Why I am doing so? Such that you will have the fair idea that in case in future they may ask the problem based on the concept of settling time, rise time, delay time, they can frame the different kinds of the problem now. They can raise the different kinds of the problem. Tell me what would be the best most answer over there? Rise time. So as per the Amit, the rise time would decrease. Anyone else apart from Amit? Anyone else? So what I am saying, until and unless you do not have familiarity with the rise time, which used to be pi minus of phi divided by of omega d, probably you would not be able to smash this problem out. You would not be able to smash this problem out. Agreed? What had been phi over there? The phi is nothing but the cos inverse of zeta. One thing has been quite sure, as the poles has been sliding from its place, the value of phi had not been changing, and the numerator part remains fixed, at least in this kind of movement of the poles. It had been fixed. And similarly, if we'll talk about this value of omega d, may you know what had been the omega d? Omega d had been the imaginary part, and you can say the separation from the sigma axis is being keep increasing. That means the worth of omega d is being keep increasing. So the denominator factor is being keep increasing, the numerator factor had been kept fixed. One thing has been quite sure, the TR has to be decreasing in nature, has to be decreasing in nature. No, TR would be decreasing. Yeah, phi would be constant, yes, that's perfect, that's perfect. Agreed, no? So probably till this point I don't find any of the student would have any sort of doubt. Let me take this thing next. May I know what would be the effect over the TR, the way the poles had been shrinking and trying to merge at a real axis? What would be the effect over the TR? What would be the effect over the TR? What would be the effect of TR? What I am saying, the way the pole had been keep shifting towards left hand side and trying to submerge over a negative real part, may I know what would be the effect of TR when it had been sliding in this way? When it had been sliding in this way. Would it be increasing? TR, would it be decreasing? Would it remain constant? Would it remain constant? Tell me. In circular movement, what do you expect? What do you expect? Rise time, the two different kinds of the answer we have received so far. The TR is being constant. Pikorab Basu says the rise time will decrease. Tell me, rise time, will it increase or will it decrease? One thing has been quite sure, what it had been, just try to understand in this way. Pi minus of phi divided by of omega t. Omega t. Phi is continuously decreasing. If you will take the reference of this pole, the phi had been larger, had been decreased. So one thing has been quite sure, the part which is going to get subtracted at the numerator is being keep decreasing, and as it has been happening, so one thing has been quite sure, the numerator is being keep increasing. Numerator is being keep increasing. Not only that, even the imaginary part is keep shrinking. That means the value of omega d is keep decreasing, and as the numerator is being increasing, denominator is being decreasing. Undoubtedly, I can conclude the rise time is supposed to increase. Rise time is supposed to increase. Check it once, what exactly I wanted to communicate through this. Rise time is supposed to increase. So the two answers we have got it so far. Pikorab Basu, it was a wrong answer. Amit Kumar, it was a wrong answer. Because the phi is decreasing, numerator would increase, because the phi had been the factor of subtraction, and the lesser amount of value would be get subtracted in numerator. Definitely that numerator would become more and more heavier, and similarly the denominator is becoming, or the value is being reducing. Definitely TR is supposed to increase. TR is supposed to increase. Pikorab and Amit, I would like to have the input from you guys. Could you understood the concept behind this, or is still certain doubt you guys are having? Otherwise, we'll jump into the next question, and that would be the fourth question of the day. That would be the fourth question of the day. Pikorab and Amit. I think it's right time to move forward, taking the next question. Yeah, here goes the next question. Ram Nanveni, clear sir, clear dear. Okay, Amit Kumar understood sir. That's just a basic mistake you guys were doing, but otherwise from your answer I can infer you guys have done a good homework over the control system. Okay, anyways, read this problem carefully and tell me what would be the best most answer for this given problem. The transfer function of a plant, again I am saying it could be the chemical plant, it could be the mechanical plant. So what I am saying, you need not to worry from where the transfer function had come. You had to focus over the transfer function itself. You had to focus over the transfer function itself. The transfer function of a plant is Ts is equals to of 5 divided by s plus 5 getting multiplied with the s square plus of s plus 1. The second order approximation of the Ts using the dominant pole concept is being 1 divided by of s plus 5 getting multiplied with the s plus 1, 5 divided by of s plus 5 into s plus 1, 5 divided by of s square plus 5 plus s plus 1, and 1 divided by of s square plus of s plus 1. So the two answer we have got it so far. As per the Amit, the answer had been D. As per the Pikorab, the answer had been D. Tell me what would be the best most answer. So next, within 30 seconds, you guys must be able to answer it well. Tell me what would be the best most answer for this given problem. Yes, perfect, perfect. not only DC gain, even the steady state gain should be very constant, So Ram also says the same answer, it's been D, Okay. So the best most answer is obviously D only, What does it mean by the dominant pole concept? Once you will start locating the exact locations of the pole, no, probably the poles which we are going to have, the poles which you are going to have is B net. Let me do one thing. Let me have a S-plane. It had been the S-plane, real axis of the S-plane, imaginary axis of the S-plane, and it's been the S-plane. Once we start locating the exact locations of the pole, so where the poles has been located, because of this factor you would be having the placement of the pole which would be having a complex conjugate in nature, and obviously would have the negative real part, and they had been placed at minus 1 upon 2 plus of root 3 divided by 2 getting multiplied with j, and similarly it had been at minus 1 by 2, and the another pole is being kept at minus 5, May I know what had been the substantial differences between them? You can say the time constant which was involved with 5 had been 1 upon 5, which we have already discussed earlier. As the real part of the pole keep increases, its time constant keep decreases. And what I am saying, as the time constant keep decreases, its effect over the response would be very fast, or I can say you would not be observe much of the change over the y of t because of a fast time constant where the worth of time constant had been lesser. So obviously if we'll compare these two poles with this, the real part of this two pole had been 1 upon 2 with the minus sign, and here it had been 5, almost 10 times. So what I am saying, whenever you have the significance difference between the locations of poles which had been kept towards left hand side, significance, I take at least 5 times, significance, that means at least 5 times. In that case what we can do, the fast pole can be dropped because their effect would not be that visible over the y of t, over the substantial amount of time, because it would come and it would vanish. But one thing has been quite sure, if you have been dropping this factor of 5, no, the response would not change. I am not saying the response would not change at all. It would change for a bit, only and only towards the transient part, but at least you had to make sure the steady state gain offered by the system, DC gain offered by the system should not change. If those values have got changed and you are saying, sir, this has been the approximate, my dear friend, the complete steady state value, the complete DC gain itself had been altered, what's the approximation? That's the hell. That's it. So what I am doing, one thing has been quite sure, sir, it had been the fast pole. I think it's the right time to drop this out. But once you are in an interest to dropping this out, no, first arrange the given transfer function into this standard form. How do we do that? 5 would be taken out of it. Okay, sir, 5 had been taken out. And here it becomes 1 plus of s divided by 5. It would remain as it is. S square plus of s plus of 1. Agreed, no? What I am saying? And similarly, the omega n square should match over here. It's been 1, and obviously what I am saying, 5 has to come out. So one thing has been quite sure, once you are arranging the given transfer function into the standard form, see, all of the factor of s had come along with a certain coefficient, and even if it comes along with a certain remaining coefficient, it had been always 1. Yes, no, it had been 1. So many of these students think a lot, sir, what does it mean by the standard form of the transfer function? In standard form of the transfer function, we ensure if s has been fed 0, omega has been fed 0, the individual terms are going to create only and only what? Unity. Now the people would also say, sir, here I can have 4, my dear friend, here you can have 4, but if it is 4 over here, in standard form, the 4 should also be over here. So this factor would always lead 1, Could you really understood what exactly I wanted to communicate through this thought process? So one thing has been quite sure, yes sir, now it's the right time to drop this out, and once we drop this out, this had been 1, and the factor which had been left out in our hand, it's been 1 divided by of s square plus of s plus of 1. Either you take the DC gain offered by this system, either you take the steady state response if the system is being excited by the unit step. Through this or through this, you would be getting the same answer. So what I'm saying, while you approximate or while you use the dominant pole approximation, few other things has to be there in your mind. The first thing, there must be at least substantial differences between the locations of the pole which we exist. Fast pole can be dropped, fast poles can be dropped, or the fast time constant, the worth of the time constant has been lesser, or the time constant which had been to a very left hand side of the S plane can be dropped. Could you understand what I am saying? Next, steady state gain and DC gain, one of the same. Steady state gain and DC gain should not change, should be unchanged. Should be unchanged. I know many of these students would also pick this as answer. No, here the DC gain had been 5, here the DC gain had been 1, here the DC gain had been 1. DC gain had been 1. So I think this must be clear cut understanding to all of us. Now in the same sequence, I think it is the right time to take the next question. Here goes the 5th question. This problem had been experienced by the electrical people in year of 2007. The problem was framed by IIT Kanpur. So let me bring this problem. It had been a type of circuit which had been connected from the second order system, Read this problem carefully and tell me what the most answer we can retrieve out of this problem. We had the series RLC which had been excited by input E of I. We wants to know RLC for EI. Which kind of the system it's been? Obviously it's supposed to be under damped system. The value of overshoot in output E naught has to be calculated. Overshoot, obviously in percentage they had been asked. So until and unless the value of zeta is not known to me, I would not be able to proceed forward. And once the value of zeta has been known to me by the help of e to the power of minus zeta pi divided by 1 minus zeta square with a square root, I would be able to calculate the percentage overdamped. Tell me what would be the precise most answer for this given problem. And you can expect this sort of problem in near future, because so far the questions which had been raised, they had been more mathematical. Circuit related problem had not been asked very much. So you can expect this sort of problem in future. Pikorab, Amit, tell me what could be the best most answer. See what I am saying? You need not to calculate the complete transfer function. I know many of these students must have been gone behind calculating the complete transfer function. Not required. You just had to focus over the characteristic equation. And what used to be the characteristic equation? The polynomial of the denominator gets compared with 0, and that's nothing but the characteristic equation. So once you calculate the characteristic equation, it's simply gonna be the impedance offered by the resistance, impedance offered by the inductance, impedance offered by the capacitance. And as we had been discussing the things in the Laplace domain, it would be R, it would be L of S, it would become 1 upon Cs. So what we would do over here, we would just focus over the characteristic equation. Where should I do that? Let me do somewhere here. let me focus over the characteristic equation first. And as we focus over the characteristic equation, impedance of R, that's simply 10 ohms. Impedance of L is been Ls, that's been 1 milli getting multiplied with S, plus of impedance offered by the capacitance is been 1 upon Cs, and that had been 1 upon 10 into 10 to the power of minus 6 of S, and now it's going to get compared with 0. Yeah, agreed, sir. Till this point I don't have any doubt as such. So now what we are going to do over here, we are going to take its LCM. And end of the day you are supposed to get the value of zeta. And from zeta you would be able to calculate each and everything. If you don't want to do so, you could have done this thing in this way. It would have been R plus of Ls plus of 1 upon Cs is equals to 0. Once you will take its LCM, what's the factor you would be having? It's going to be RCS plus of LCS square plus of 1 is equals to 0. Obviously this factor must be free from the LC, so the LC would be divided both on the side, and once the LC is being divided both on the side, what had been happening over here, it's been RC getting divided with the LC of S plus of 1 divided by what? LC is equals to 0. So here the C and C had been common, that had been knocked off. The factor which had been left out is been 1 plus of RL of S plus of 1 upon LC is equals to 0. 1 upon LC is equals to 0. Yes, no? Why I have been doing so? Because here we had the complex values of L and C, so deliberately I don't want to waste my brain as well as time. So what I am saying, the impedance offered by the resistance is been R, the impedance offered by the L had been L of S, the impedance offered by the capacitance is 1 upon Cs, and now we would take the LCM both on the side. So what happens, the RCS, it becomes LCS square plus of 1. This factor has to be free from LC. So now the LC had been divided both on the side, so here it become RC divided by LC plus of 1 divided by LC is equals to of 0. 1 upon LC divided by 0. Agreed? Let me do one thing. Let me compare with the standard form of the second order systems characteristic equation, which used to be something like this. And my focus is still on zeta. What I am saying, my focus is still on zeta. So one thing has been quite sure, the value of omega n is been 1 upon root over of LC. Yeah, the value of omega n had been 1 upon root over of LC, and similarly 2 zeta omega n, where the omega n is been 1 upon root over of LC, is been in the place of where? R by L. So zeta can be calculated easily. May I know what would be the worth of zeta in that case? R would remain as it is. Here it would come root over of LC divided by of L, and the 2 would come towards downside. Agreed, no? So here it becomes zeta 1 upon 2, R would remain as it is, and here it becomes root over of C by L. Could you understand what had been the psychic behind the complete calculation? What I am saying, whenever you have the complex values, specifically in transient analysis, specifically in control system, rather taking and using those values, you could have used this format. Yes. So here it becomes 1 upon 2. The R is known to me. Now the calculation would become much easy. You yourself would be able to judge it. Root over of C, what had been 10 into 10 to the power of minus 6, that had been 10 to the power of minus 5, divided by the value of L, that had been 10 to the power of minus 3. Put together how much the value had been? It had been 10 to the power of minus 5 divided by 10 to the power of minus 3, that becomes 10 to the power of minus 2. 10 to the power of minus 2 had been raised to the power of half, that's going to be 10 to the power of minus 1. 10 to the power of minus 1 into 10 is simply going to be 1, and the value of zeta which we are going to get, it's simply going to be half. What I am saying, the value of zeta which we are going to get is simply going to be half. Such a well designed problem it had been. Although such a vague number of L, C and R had been given, but once you will do in systematic manner, you got the value of zeta as half. half. And now it had been the right time to calculate MP percentage that used to be e to the power of minus zeta pi divided by of root over of 1 minus of zeta square. 1 minus of zeta square. Once you will do this all stuff of calculation, after this all calculation, probably the answer which we are supposed to get, it's going to be 16%. So whoever have got the answer 16%, that is only the correct answer. That is only the correct answer. May I know, out of the 7 number of live people, how many could get this answer? I know most of us could not. Ram had given the answer for the last question. So it had been the special category of the problem where they had been asking for the MP, peak overshoot in percentage, and this has been sort of this. That means if the input is going to be unit step input, the response is going to be sort of this. And we had been focusing over the MP percentage. How do we calculate the MP percentage? Let's take this value had been, what we can take, A, and this worth had been B. So here we take A minus B divided by of this. Agreed? Anyways, this has been the agenda. 16%. Took sir too much time while solving. This problem had been the standard problems on the gate now. Okay, Amit, we will try. Okay, now it's the right time to take the next question. Probably we have come across the next question. Where it had went, yeah, here it had been. 6th question had come in front of you. The problem had been experienced by the electrical people in engineering services examination in year of 2018. The problem states the transient response of second order underdamped system is starting from rest is being given as Ct is equals to A e to the power of minus 60 sine of 8t theta when the t is being greater than equals to 0. The natural frequency of the oscillation would be. Tanjim Khanam, thanks dear. So let me focus over the 6th question first. Tell me what would be its best most answer. See, deliberately they have altered the problem a bit. What they are saying, the transient response. May I know what used to be the transient response? The response which had been changing its worth, and before going into the steady state, it vanishes. Theoretically speaking. So what I am saying, for the second order system, y of t which is being defined as 1 minus e to the power of minus zeta omega n t divided by 1 minus of zeta square sine of omega dt plus of theta. What used to be that? It used to be the complete response. What I am saying, as far as the second order, standard second order system which had been underdamped, had been excited with the unit step is being defined as 1 minus of e to the power of minus zeta omega n t root over of 1 minus of zeta square, and here it's going to be sine of omega dt plus of phi. But one thing has been quite sure, over the period of time this would be dominating and this factor would be vanished, and end of the day at t tends to infinity it would be settled down at k. But in this problem the value of k had been taken as 1, so remove this. So what they have given? They have given only and only transient part. This has been the steady state part. In the complete response, if the steady state part had been removed now, obviously you would be left out with the transient part. So this has been the transient part. The A had been minus root over of 1 minus zeta square, everything. But they had been looking for the value of omega n. Omega n can be easily calculated. How omega n can be easily calculated? We know the omega n could have been taken as the square of zeta omega n plus of omega d square, and from here easily you can get the value of omega n. Agreed what I am saying? Once you will compare, the value of zeta omega n is been known to be 6, and similarly the value of omega d is been known to be 8. So the omega n is simply gonna be Zeta omega n, how much it had been? 6 it had been, has to be raised to the power of 2. Similarly, omega d, how much it had been? 8 had been raised to the power of 2. Put together, the result which we are supposed to get, it's been C. It's been C. Yes, sir? Till this point, probably each and everything must be clear to all of us. I think it's the right time to move forward taking the next question. This was experienced by the instrumentation people in year of 2008. The problem was framed by IIC Bangalore, and it had been a type of linked problem. That means the answer which we are going to get from the first question is going to serve as the input to the second question. Input to the second question. Tanjim, Khanam, what are the different subject ideal? The total 5 number of subject ideal, which starts from control system, goes to the mathematics, goes to analog, goes to EMFT, and ends to the devices. The 5 number of subject ideal. Read the problem carefully. Probably it would be the last 2 questions of the day. Last 2 questions of the day. The problem states a unity feedback. What does that mean by the unity feedback? That means a system had been designed in such a way that the factor of feedback had the worth of 1. Has the open loop transfer function. The open loop transfer function is being given. The time at which the response to a unit step reaches to the peak is pi by 8 seconds. The damping coefficient for the closed loop system is. Tell me what would be the best most worth for this given problem. I would like to have the input from each one of you. From tomorrow onwards, definitely we are going to switch to the next topic. Which topic I should take from the tomorrow onwards? I know because many of the students used to have several kinds of the doubt. I know which are the different topics where you guys are having more doubts. You can put it or you can suggest those topics which I can start from tomorrow onwards. Read this problem carefully and try to get its best most answer. State space is comparatively easy, I would say. Nyquist, yeah, see, either of the topic within the control system is easy only. Root locus, the 3 different input I have received so far. I expect Nyquist because in compare with the state space as well as the root locus, I think the Nyquist is bit difficult. I won't say difficult, bit more conceptual, you can say, Anyways, tell me what would be the best most answer for this given problem. We will see which topic we are going to take. Maybe I can take Nyquist or I may take a root locus. I won't take state space straight away because we had to learn few more important things. Then only we would switch into the state space. Anyways, tell me what would be the best most answer for this given problem. It should not take more than 3 to 4 minutes to smash this problem out. No one? Okay, let me read this problem carefully. Unity feedback has the open loop transfer function, everything has been known to me. What we have been doing over here, just a minute. So the answer has started coming as per the Khanam, answer had been 0.6. As per the Amit, answer is been B, and P is 12. Khanam, you are doing extremely well, perfectly well. Amit, you are also doing extremely well. Both of the answer had been pakka, perfect. Both of the answers had been perfect. Perfect, perfect. Picorub, perfect. So I can say they had been just an simplest form of the problem. Here we had the g of s. Easily with the help of g of s you could have got the characteristic equation. May I know how the characteristic equation would be defined? Characteristic equation would be 1 plus gs hs. As the value of hs had been 1, so simply it's gonna be 1 plus gs, which would get compared with 0, And once we do so, we will, after taking the LCM and all, the factor which we are going to get, it's gonna be P of s 100 is equals to 0, agreed? So at least two important data we could retrieve out of it: the value of omega n, that has been 10, the worth of omega n square has been 100, so the value of omega n has been 10, 2 times of zeta omega n, 2 times of zeta omega n, and that had been 10, and the worth had been given as p, so obviously the zeta had been p divided by 20, agreed? And at the same time, the time at which the response to the unit step response reaches to the peak is been pi by 8. How it's been defined? It's been defined as a peak time. The peak most value would occur at the first overshoot itself. So here it becomes n pi divided by omega d. The value had been 1. This value had been given as pi by 8. Probably everything has been known in our hand, no? Everything is known. And I would say, so many questions we have taken so far, you guys would be able to relate this very well. So Nissan, perfect. The answer, the bestmost answer had been option B alone. Yes, option B alone. Tick. So at 9 PM we are going to have the exclusive session on the BRC. As I have worked in BRC for the 5 years, so definitely I had a little bit idea how the work used to be there in BRC. I won't talk much about the BRC. I would talk about the preparation, procedure of return, procedure of gate in the night session. Okay. So I expect all of the 12 people would be there precisely at that time. Till then, bye bye, take care, good night. ठीक है